the second half. So we'll do this one as fast as we can right now. I'm going to ask for a random volunteer. Probably Moses, you're going to start today for me. Do you recall from the last 2 days the first step here in the square? You're going to divide the first two terms both by 3. Now in this case I was nice because that factors out beautifully. All right, Mackenzie, do you remember what the second step is, please, in completing the square? Very good. Yeah, I know what you're saying. Oh, that's a fraction. Yes, it is a fraction. Don't worry about that. Liam, can you show off your mathematical skills and tell me what negative 3 over 2 times negative 3 over 2 is, please? What's 3 times 3? 2 times 2? 4. Good, so it's 9 over 4. And that turns to underline its number. Okay? I'm trying to do this with my paper today. If I say your name wrong, I apologize. I'm going to try and do this out of memory. Okay? Jordan? What's the next step here, please, that I do? Do you recall?
You add, subtract 9 over 4.
Very good.
Can you write on the other side of that, or just on the one that's currently highlighted?
No, I can write on this one too. Just so I want it so that if even if I'm a little bit ahead of people, they can still catch up a little
Yeah, I
bit.
was kind of curious.
I wanted to call you Nathan. I knew that wasn't right. Nicholas, what do I do now, please, if anything?
We've got to subtract the fraction.
Your phone's talking.
Is that me?
Yeah.
Yes, you subtract the brackets. So what do you do to take away the brackets? Remember? I'll help you. You got to multiply by this number here, right? So it's going to multiply that times that. Okay, so y equals 3. X squared minus 3x plus 9 over 4 minus 27 over 4 plus 4 over 4. All right. Rachel, why the heaven did I change that to 4 over 4? Well, you're adding the fractions, so it has to be there. You don't get off that easy though. What is this factor to? This right here. I'm not going to save you today.
1 second. Okay, so 9 over 4.
Matt, I didn't. The microphone, I don't think picked that up.
Okay.
But Matt, do you remember how we factor this?
Yes.
Sorry.
Like covering 3
Oh, careful, no, careful. We've done all that stuff right there. Okay, so what do we do just to factor this? You freezing, sorry, are you freezing?
Not right. Doesn't we like take it out and square it?
Sort of. Not really though. Jack, go ahead.
Yeah, a number in the box, or the number that we did.
That's the one we use right there. Okay. So it's going to be 3 bracket x minus 3 over 2 squared minus 23 over 4. Just wait. Just wait. Moses, go ahead.
We always have to use the fractions. I would just use a decimal.
No, math, you need exact numbers. And your calculus teacher next year will be upset with you if you use decimals. Thirdly, and this is this is the first of a million times I'm going to say this, some university programs do not allow calculators in first year. Okay, so don't say, oh my goodness. So the point is, it's a lot easier to deal with this than 1.5 squared and all that stuff. You don't want to get into that. Okay, so leave it as a fraction with these small numbers. Yes.
Saying exact numbers, that doesn't really help like as an argument for fractions because decimals are exact, like
right.
Exact.
Until I get 4 over 3 though, right?
Just point that out, like they're
Yeah,
a lot more
until-
exact. Like,
No, fractions are the more exact. Let's say I have this. Well, this isn't. Right? You don't want to square that and try and get it right.
yeah, but you can't really make that into a fraction either because
Yeah, you can.
that doesn't indicate that's like practically infinite.
Watch. I'm not going to play the fraction. I'll play the fraction game on Monday. Okay, let's continue. Please go ahead.
What if you have like a fraction and then you're dividing it by 2?
So let's say I had like 2/3, something like that, divided by 2.
Yeah.
Let's pretend. So that would be squared. So I change that to 2 over 6, right, because the denominator is getting bigger, which I'd also change. I change to 1/3 and then squared 1/9. So that would be your underlined term. So this would be the one that goes up here. Okay, and this would be again. All right. Oh, I was trying to do this without names. Just wait. It's not coming. I'm sorry. Caleb. Sorry, Caleb. Caleb, what's my vertex and which way is it open, please? Yeah. Yeah. Very good. Okay. Now for domain and range, you can graph this if you need to, but we don't have to. Do you want me to do, Taryn, do you want me to do a little graph for you to make it easier? Or can you do the domain and range without seeing the graph?
Sure, go for it.
Go for a graph? Okay. So my vertex, excuse me, here's a little tiny graph. There's 3 over 2. There's negative 23 over 4. And my graph is, there's my vertex like this. It's going to look something like this. Okay? Ballpark. Okay? It's going upwards. Yeah. Oh, good question. It's whatever this coefficient is. And you can actually get it right from the beginning. Because it's positive, positive opens up and negative opens down. Okay? All right, so Taryn, you're not done yet. What's the domain for this? What are the possible x values for a parabola that's getting wider and wider and wider forever? A real number. Okay, so my domain is going to be Taryn, before I ask you your next question, or a personal question to ask you, I hope you don't want to answer it. You're up what you ate for breakfast?
I had 2 pieces of whole grain toast and peanut butter.
Excellent. Okay. What's the range, please, for this in English? In English. Bro. Well, what's the key point, Karen, before we just worry about it? No, x is a real number. The problem is these numbers don't work for y, right?
Yeah.
So what are you going to say? What's the minimum number for y?
Negative 23.
Right, so y has to be bigger than negative 23 over 4. Okay. Bigger equals, thank you. Yeah. Yes, vertex form will always give you a parabola, yes. That's why we like vertex form, because it's easier to find. Now, Rachel's been staring at me with evil eyes for the last 2 days because she knows a faster way to find the vertex than what we've just been doing. I'm going to show you that method if you want to use it. Okay? The point is, this is good algebra, and we need algebra in this class. That's why we do it this way. Okay, here's the fast way to find a vertex. Are you ready? Okay, Ian, I'm going to embarrass you if you don't mind. Can I embarrass you? Is that okay?
Yeah, that's fine.
Okay. A few days ago, Ian came in to ask for help at lunch, which is a good thing. That's not the embarrassing part. He said to me, there's got to be a better way to find a vertex, and I showed him this method. The embarrassing part is it took you, like, what'd you say, 5 minutes to do question 8 last night? I don't know how long it took. 10 minutes? Not a long
That's
time.
embarrassing, but
Yes, it was very, very fast until you do number 8. Okay, so I'm going to show you the very, very fast way to find vertexes. Here we go. Are you ready? To get the x value, if something is in standard form, your x value is equal to negative b over 2a. And y is equal to f of negative b over 2a. Rachel, just the way you're thinking of? Find the vertex? If it's faster than my way, then that's cool. Okay, but I think this is the fastest way possible. Okay, so what this is the quadratic formula, plus or minus 0, so if the vertex is right on the line. Okay, now you don't have to memorize this method. If you prefer to complete the square, you may. All right, but this is the faster way. So I'm going to go back to the same question we just had, which was y equals 3x squared minus 9x minus 1, or plus 1, what was it? Plus 1, thank you. Okay. Who are we up to? Andy, can I embarrass you and tell them where I saw you last night? I saw Andy upstairs, and she was looking at me, and I was looking at her, and then all of a sudden I did this, and she said she thought it was my brother that she was staring at there. That's why she didn't.
I didn't, yeah, I wanted to see what you said.
Okay, just so you know. Okay, according to this equation, Andy, what is B and what is A in that equation?
Oh. Okay, B is 1.
It goes A, B, C, right? Yeah, A, B, C.
Yeah.
So B is -9, yeah.
And 2.
So over 2 times 3. Which happens to be positive 9 over 6. In those terms is 3 over 2. You want to see something amazing? If you go back, what was the vertex on the last page? Hopefully it was 3 over 2. Okay? Now that's my x value. How do you get the y value? Well, we just subbed it into the equation. Okay? So y is going to be f of 3 over 2 equals 3 times 3 over 2 squared minus 9 times 3 over 2 plus 1. Now, please be brave and ask rather than just nodding your head and saying all is well if you don't understand what just happened. All that happened, I see one shaking head, that's good. All I did there is I took my value for x and I'm going to sub it into the main equation to get y. Logan, how are you feeling? Just coming back? If it's not, it's okay. This is an optional method here. Okay, okay? Yeah, you should find the x with 3 over 2. So that's all I'm doing.
No, why did you get equals F?
Well, this just means sub 3 over 2 in your equation. That's all it means.
So like, you're saying f of x is f3 over 2?
Yeah. That's all I'm saying is sub 3 over 2 into the equation. That's all.
3.
Oh, okay, so can you slow down here? So this number right here is this number here, right?
Yeah.
And then this here and this here are this and this. So I sub it back in my original equation. Okay, so I replace x here with 3 over 2, so it goes to square. Replace x there with 3 over 2. It just goes to like that. Okay, does that make sense? I just subbed it right in. Okay? Yeah,
Where
right?
do you get 3 like in the middle?
This one right here? This is this 3 right here. I'm subbing it back into this equation.
So you're gonna take add the
Yes, the original equation. That's what I was trying to do. Okay, I'm going to do this fast if you don't mind. Okay, so I'm going to say y equals 3 times 9 over 4 minus 9 times 3 over 2 plus 1. That turns into 27 over 4 minus 27 over 2 plus 1. Okay. Now Moses is saying to himself, why don't I just turn these to decimals? And I say, shame on you. This is grade 12, you guys can do fractions. Okay? How do you add fractions? What do you need for all of them? Common denominator. So it's going to be 27 over 4 minus 54 over 4 plus 4 over 4, which originally is negative 23 over 4. So my vertex is 3 over 2, negative 23 over 4. Either method is okay. Now the other question is, how do I know if this opens upwards or downwards? Can somebody tell me how I know if this opens upwards or downwards? What's the key number I'm looking at? 3. You're looking at back to all the original equation. This number right here, we should do it in a different color. This number right here is for up or down. Did anyone see this last year at all? One person saw it? Thank you. Very good.
Is there any benefit of completing the square root of this?
The benefit is these fractions, you can make a mistake very easily with, like, is this a little more algebra? This is where they teach you in grade 10 because they want you to get good algebra skills. That's the main reason they do it.
So this is a lot easier.
Yeah, if you want to do this way, that's fine. It's not going to be a big part of the course at all. This isn't, but I just wanted to show you just to speed it up. I'm learning transformations right now. I'm getting on.
What does that mean?
V is vertex, right? V is vertex. That's right.
Okay, you can also find the vertex, so if you have both zeros, then x goes straight in this.
Very good, yeah. But the problem is for this one, you could do it that way. You have to complete, you have to watch the formula before you do it.
Well, because last night, one of the questions that was already in last week's one,
Yeah.
was already gave zeros, so you included.
Yeah, fine. Very good. Awesome. Wonderful. Tremendous. give a hand or stretch? Anybody else? Somebody have a hand over here? Hi, how you doing? Good? Good? All right, here we go, transformations. Transformations. Okay, you guys did a lot of this last year, and we are still going to need it this year too. It's something like this. I don't remember the exact equation. Something like that. Is that what sort of close? D and C for what? D here. Okay. Okay. All right. Now this is something you need to know, and I'm going to do two examples after this to make sure we're not going to graph anything or transform, but just to understand what the transformation is in English. Thank you. All right. A is going to be your vertical stretch. Which means you're going to multiply your y values. Okay? So vertical stretch means that you're going to make the graph taller, okay, or whatever it is. That's a vertical stretch. You're going to multiply by y. And you guys probably did that when you graphed exponential graphs last year, remember, right? You'd be like just multiplying the coordinates. Does that make sense to a few people? Okay? We'll do these all in different colors today. K is going to be the horizontal compression. Divide your x values by k. Okay, so let's say you had an f of 3x. That would mean that your y values are going to be divided by 3 and the graph would get smaller like this. Okay? Does this come back to anybody? One person nodding said, thank you very much, I appreciate it. D is going to be a horizontal shift. Meaning you're going to subtract x by b. And C is going to be a vertical shift. And that's going to be add C to x. Okay, hopefully those four things look somewhat familiar. One of the main benefits of having a function is you can do this to any function and do the transformations. And I think you guys did a lot of transformations last year, if I remember, grade 11. Is that a question or just your...
Oh.
Go ahead.
Wouldn't the vertical shift be, you're adding to the y, not the x?
Did I say yes? You're correct. Vertical is y. Sorry, I was talking. I can't talk and think at the same time. Thank you. Sorry. Yeah.
Saying like horizontal shift is
Yeah.
basically the same as saying like a translation left or right.
Yes, yes. Yeah, sorry, it's horizontal translation, that some people call it too. I just call it shift, but it means the same thing. Okay, so what I'm going to do is I'm going to pick 8 people at random, starting with Paula. Okay. Now, just before you freak out, don't freak out, okay? You can do this. Secondly, you have the transformation page right in front of you here to help you. But this is something that you need to be able to do for yourself, okay? Eventually. So here's example 1. Translate into English. Y equals negative 3f of 2x plus 3 minus 4. Okay. Now before you freak out, take a deep breath. You can do this. Okay, so we're going to just go left to right. What does that negative 3 mean? Which one of these is going to be?
It's the vertical stretch.
Right. So it's going to be vertical stretch. Of negative 3. What that means in English is multiply your y values by -3.
I thought it was like lower than 1 was like a very
Between 0 and 1 it would be. If it was between 0 and 1.
Maybe we can do some like steps.
Yeah, I'm just gonna go left, right, I'm just gonna go 1, 2, 3, 4. Yeah, go ahead.
When it's like the -3, does that mean there's like a reflection?
There's a reflection there too. I don't do a reflection, I just call it a vertical stretch of -3. The negatives imply to the reflection. Some teachers make it like, Mr. Walter, he's a good person, okay, but he does his transformations that you have to do every single, so if you do a parabola, then you do this one, then you do this one, then you do this one, then you do this one. Is that what had Mr. Walter for grade 10 and 11? Do you have? So you remember all those graphs, and you just do 4 graphs or 5 graphs on one page. This way you can go right to the final answer using transformations, which is better. Not better, don't tell Mr. Walter I said that, but it's more efficient, okay?
Yeah, so instead of making multiple graphs, are we just making a chart with all the values?
You can do a chart and probably just do the final graph. You don't need to do the original graph, of course. Okay? All right. Evan, I'm sorry about that. What does Z2 mean, please?
Q is the horizontal compression.
Good. Okay. So horizontal compression. Of 2. So it's going to be divide x values by 2. Okay? So basically if I have x values of the original function of 2 and -2, now it's going to be 1 and -1. Okay? Make sense? Jake, I wanted to call you Luke, I knew that was wrong. Sorry, Jake. Jake, what does the 3 mean?
You're shifting the x values by -3.
Yeah, so you're going to go left 3 is what I'm going to call it. Okay, so +3 on here is actually means you're going left 3. So it's going to be a horizontal shift of 3 left. So we're going to subtract 3 from x. Now somebody's going to say, Mr. Sadler, I don't understand why that is. Okay, think of it like you're solving for x. Okay, on that inside bracket, I'm going to divide x by 2 first, get rid of the 2, then I'm going to subtract 3 to isolate x. Okay, so think of it the same rules as that. All right, Kai, you're wide awake, right?
Yep.
Good. Can you tell me please what that -4 means?
It's vertical shift.
Thank you. And you're going to subtract 4 from y. Okay. Is that enough, or do you want me to go through another one? Is that okay? This is sort of coming back from last year. You just needed a reference. And I'm sorry, I forgot this on 11 and 12. I didn't get through my whole lesson again, as usual. That will not happen again today. Okay. All right.
If it does happen again, like we noticed, do we just not?
If something's weird, yeah, because we're on to totally new material from here on out. Okay, so if you could look at a question, you say, I have no idea how to do this. Just someone confront me about it the next day, saying I didn't know to do number 7 or whatever, and we can take it up. Okay, so I apologize. I made those, you know what I mean, the homework. I first picked them on Tuesday, right, and the whole thing. All right, does this sort of help clarify things a little bit?
Sort of a little bit.
Good. That's positive. That's positive. Okay, we're moving in the right direction. All right, Lucas, you're going to be my hero today. You're up next. Are you ready? All right, we're on to the new unit, though, which you didn't realize. I'm going to pause the video and give Lucas a minute to get ready. Starting now.